All right, let's dive into something really fascinating today. You know, you sent over that YouTube video about Christian Barrios and his theory.
Yeah, it's pretty wild.
It's a wild ride. This guy, an independent researcher, thinks he's cracked the code of dark matter.
Mm,
And you won't believe this, it all starts with something you probably have in your junk drawer.
okay, I'm intrigued. What is it?
A pinhole camera?
The pinhole camera.
Ever thought about why the image in a pinhole camera is upside down?
Well, yeah, I mean, it's basic optics, right?
Well, that's where this whole thing gets interesting. Barrios takes this simple observation and just runs with it.
Okay.
He notices that not only is the image flipped, but it's also super clear considering all these beams of light are converging in that tiny hole.
It's like a cosmic traffic jam in there.
Right. But all those light beams, they just like squeeze through without any fender benders.
So how'd they do that?
Well, the secret sauce, according to Barrios, is that light, or rather these little particles that make up light called photons, are massless.
Okay, yeah, I remember learning that. Photons, massless.
They're like tiny ninjas just zipping past each other. No collisions, no drama.
Okay, I'm with you so far.
So Barrios, he's thinking about this, and it gets him thinking bigger. He realizes if this is happening at the pinhole of a camera, it's happening everywhere, constantly, across the entire universe.
He's thinking about the universe on a pinhole scale.
Exactly. He even calls this crazy convergence of light a spooky tangle.
Suki Dangle. Okay, now I'm really interested.
Imagine like the entire universe is a room and everyone's pointing laser pointers at everything else.
Okay, I can picture that.
Barrios is basically saying that the combined energy of all those invisible beams, that's what we're perceiving as dark matter.
Whoa, hold on. So you're saying all this light energy is just out there. Wouldn't we be able to see it?
That's the million-dollar question, and Marios has a really interesting explanation. Think about shining a flashlight in a dusty room.
Okay, yeah.
You see the beam, obviously, but you also see all those little dust particles light up. They're illuminated by this scattered light that you wouldn't normally notice.
Okay, I see where you're going with this.
Barrios thinks that something similar is happening on a cosmic level.
Okay, I'm listening.
He's suggesting we only see a fraction of the light that's out there, just the stuff that hits our eyes directly.
Okay.
But there's a whole lot more of it, this kind of invisible sea of electromagnetism that we just haven't been accounting for.
Interesting. So it's there, but we just can't see it.
Exactly.
Like trying to see the wind.
And this is where it really starts to get fascinating. Because Barrios goes on to explain how this electromagnetic density, this invisible light, could actually explain some of the weirdest things about dark matter.
Okay, now you've got me hooked. Tell me more.
So we've got this invisible sea of light, this electromagnetic energy, possibly holding the universe together.
It's a bold idea for sure.
But how does it actually explain what we know about how dark matter behaves? Like, we know it clumps around galaxies.
Right.
Does Barrios' theory explain that?
It does, and it's kind of beautiful, actually. Think about it. Galaxies are like massive cosmic power plants, just churning out light and all this other electromagnetic radiation.
Okay.
So naturally, you'd expect a denser concentration of this invisible light in those regions.
So it's like moths to a flame, but instead of moths, it's invisible light, and the flame is, well, the entire galactic center.
Exactly. And according to Barrios, this denser electromagnetic energy, it translates to a stronger gravitational pull. And that's exactly what we observe with dark matter.
Oh, okay, I see. So the more you pack into a region of space, the stronger the gravitational influence.
Precisely.
Okay, that makes sense. But what about those filaments of dark matter? You know those vast web-like structures that stretch across the universe, connecting galaxies over these impossible distances?
Right, the cosmic web.
How does Barrios' model explain that?
All right, well, this is where it gets really interesting. Imagine you're shining two flashlights towards each other in a smoky room.
Okay, I can picture that.
You would see a brighter region where the beams intersect, right?
Yeah.
Barrios thinks something similar happens on a cosmic scale, but with light we can't see.
So these filaments, these cosmic superhighways of dark matter, they're like bright spots, where the invisible light beams from different galaxies are all crossing paths.
That's the general idea. It's
Yeah.
like each galaxy is sending out these invisible beings, and where they overlap, you get these concentrated regions of electromagnetic energy, the filaments of dark matter.
It's amazing how Barrios connects something as simple as a pinhole camera to like the very structure of the universe. It kind of makes you realize how everything is connected.
It's a fascinating thought for sure.
But let's talk about how Barrios went about actually getting his theory out there. I mean, it's not easy to challenge conventional thinking, especially when you're an independent researcher.
Huh? Right, he's definitely going against the grain.
So we've got this incredible theory connecting invisible light to the universe's greatest mystery.
It's pretty out there.
But how does someone with like a pinhole camera and a really radical idea
Mm.
get the attention of, actual scientists? It's not like there's a hotline for groundbreaking theories.
Yeah, good luck finding that number.
So what did he do?
Well, what Barrios did next is really interesting. He turned to AI for help.
Wait, he asked a computer to check his work?
Yeah, kind of.
That's pretty next level. Did he just like type it into a chatbot?
He went a little more high-tech than that.
Go.
He actually engaged with those super advanced AI systems like, Claude 2.0 and GPT-4.
Oh, wow. The really powerful ones.
Yeah, and even Google's Gemini. These AIs are designed to actually understand and process complex information, not just spit out canned responses.
So he fed them his theory, all the details about photons and electromagnetic density.
Exactly.
And what did they think?
Well, remember how we were talking about how elegant Barrios' theory is?
Yeah.
The AI picked up on that too.
Really?
One of them, I think it was Claude 2.0, actually called his work compelling and grounded in fundamental physical principles.
Wow, high praise from a supercomputer.
It even went so far as to say that his ideas were worthy of serious scientific examination.
Talk about validation. Especially after I'm assuming he probably faced some pushback from, the old school science world.
It really is remarkable.
So the AI gave it a thumbs up. But did it stop there? Just feedback.
It gets even more wild. The AI didn't just validate his logic. It actually helped Barrios develop a theoretical framework for his model,
Wow.
and even a mathematical equation to represent it.
Hold on. So it's like having a super-powered research assistant that can crunch numbers and connect dots in ways our human brains just can't.
Precisely.
That's amazing and also kind of intimidating. To think AI could be helping with scientific breakthroughs like this.
It's a brave new world.
But it sounds like not everyone was ready to embrace the AI revolution.
Unfortunately not.
What happened when Barrios tried to share his findings with a scientific journal?
Well, this is where the story takes a turn.
Yeah.
Despite this incredible AI validation, the astronomer reviewing his paper basically dismissed it outright.
Oh, no, really?
Said that dark matter's not electromagnetic, which is still the prevailing wisdom in the field.
That's heartbreaking after all that work and such a fascinating theory. It makes you wonder how many other groundbreaking ideas are out there just waiting for someone to, listen. Even in science, sometimes it's hard to get people to see things in a new way. So, what's next for Barrios?
Well, despite this setback, he's pushing forward.
Good for him.
And remember, this whole dark matter thing is just one piece of the puzzle for him.
Oh, right. He's also tackling dark energy, the mysterious force that's pulling the universe apart.
Exactly. And he actually thinks the same principle of electromagnetic energy density could be at play.
So the universe isn't just held together by this invisible light, it's also being pulled apart by it.
That's the gist of it. It's like this cosmic dance, push and pull, all driven by the same fundamental force.
It's mind-blowing and definitely something to think about. This whole deep dive just goes to show that the most incredible discoveries can come from the most unexpected places. Sometimes all it takes is a fresh perspective and the willingness to look at things in a new light. What do you think? Is Barrios onto something huge, or will his theory just fade away?
Only time will tell. But one thing's for sure, his journey is a powerful reminder that the universe is full of mysteries, and maybe all it takes to unravel them is a little bit of curiosity, a fresh perspective, and maybe a little help from our AI friends.